Welcome friends. In this video we are going to revise questions from Science Paper 1 for the year 2017, and this paper was written by the internals. Now let's look at question 1 from section A. Which of the following instruments can best be used to measure the internal diameter of a pipe? So if we are looking at the internal diameter of a pipe, it can be measured by a vernier caliper. So vernier calipers has also the ability to measure the internal diameter of a pipe. Now for question 2, a stone has a mass of 390 grams and a density of 2.7 grams per cubic centimeters. Cooking oil has a density of 0.90 grams per cubic centimeters. What mass of oil has the same volume as the stone? So we are saying if the cooking oil has the density of 0.90 grams per cubic centimeters, so we want to find its mass, that if we are to measure the volume, that volume must be equal to the volume of the stone. So here we are going to do this. We know that the mass of the stone is 390 grams and its density is 2.7 grams per cubic centimeters. Then for us to find the mass, we are going to use the density. So say density for cooking oil is 0.9 grams per cubic centimeters. Then here we put x, we cross multiply. So 2.7 grams per cubic centimeters times x is 2.7 grams per cubic centimeters x. Then we'll say 390, we need to multiply 390 by 0.90. So I'm getting 351. 351 I'll say grams per cubic centimeters and grams. Then we divide by 2.7 grams per cubic centimeters, even here by 2.7 grams per cubic centimeter. So if we cancel, we have x is equal to, so 351 divided by 2.7. So according to my calculations, I'm getting 130 grams. So this is the answer. Okay, so we move on. So we move on to question 3. The diagram below shows an extract of a tape from a tape vibrator that was connected to 50 Hz AC power supply. Determine the time taken between points A and B. So what we are going to do, the first step is we are going to divide the ticker tape where we have this letter. So here you need to draw a line here. Also we are going to draw a line at B. Then we are going to count the circles or the dots that we have in between these two letters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is giving me 10. So time will be, you get the boxes, which is 10 divided. Well, first what we can do is, before we look at 10, first let's find for 1. So say 1 over, we have been given the frequency, so the frequency is 50. So 1 divided by 50. So if you do that mathematics, you are getting 0.02. So this means that each dot has the time of 0.02. Now for us to find the total time for these 10 dots, this 0.02 will multiply by, there were 10 dots. So if we multiply by 10, the final answer will be 0.2 seconds. So this is how you calculate the time given the ticker tape vibrator. We move on to question 4. The diagram below shows a box of mass 2.5 kg placed on a table. So we know that if we place this box on a table, there will be a force exerted by this box toward gravity, and which is, we know that this force is weight, and we know that weight is equal to mass times gravity. There will be another force that is opposing the weight. Now the question is, what force is exerted on the table by the box? So here, whenever we want to find the weight that is bringing toward gravity, we just have to find weight is equal to mass multiplied by gravity. So the mass is given and it's in kg. Then gravity, it's 10 Newton per kg. So if we cancel and we multiply 2.5 times 10, will give us 25 Newton. So this box exerted 25 newtons toward gravity. So our answer is C. We move on to question 5. The diagram below shows a wheelbarrow carrying a load of 100 Newton by applying an effort of 20 Newton. What is the mechanical advantage of the wheelbarrow? So in this case, the wheelbarrow is acting as a simple machine, and we want to find a mechanical advantage for a simple machine like this one. So the formula for mechanical advantage is equal to, we need to find the load, then divided by the effort that was applied. The effort is the force that was applied, and in our case we can see that we have been given this. So this is our effort, this is our load. So we can just do the substitution. So on top we are going to have 100 newtons, then we divide by the effort, 20 newtons. So we know that we can cancel the newton, 0, 2 into 10 will just give us 5. And you can see that there are no units here. So mechanical advantage is a ratio. So our answer is just 5. We move on to question 6. The diagram below shows a beam pivoted at one end and a force of 5.0 Newton acting on it vertically. Then if the beam is in equilibrium, what is the weight of the beam? Okay, so this means that we have the pivot is here. So the pivot is just where this arrangement or the beam is turning, whether up or down. Now for questions like this, we are dealing with the moment. So we have two moments. There is the first moment here, we'll call it moment 1. So the moment 1 is going up. Then there is another moment 2 which is going down. So for this arrangement to be in equilibrium, the two moments must be equal to each other. So we are going to say moment 1 must be equal to moment 2 for the beam to be in equilibrium. Now what is moment 1? So moment 1 will be, we'll say force 1, which is the one that was acting on it vertically, times the distance. The distance is measured from the point of action up to the point where there is a pivot, so multiplied by distance 1. Then moment 2, we are going to say force 2 times the distance 2. Now take note, the distance is always measured from the pivot to the point of action, regardless where the point of action is located. Now, what do you mean by that? So say here, the point is here. The distance from here up to here is just 2.0 centimeters. Then from here up to here is 3.0 centimeters. Now, so we'll call this one is distance 1. The distance 1 is just from the pivot up to where the 5 Newton is. So it's 2.0 centimeters multiplied by 5 newtons is equal to force 2 is what we are solving for, times then distance 2. Distance 2, we need to add these two distances. So we'll add 2 centimeters plus 3 centimeters. This will give us 5 centimeters. So if we divide by 5 centimeters, also here by 5 centimeters. So we know that if we cancel 5, then force 2 will be just 2 newtons. So this is our answer, which is D. So we are saying if we are to multiply 2 times 5, we get 10. 10 divided by the 5, we get 2. So this means that the force that was pulling the beam down was 2 newtons, so that it remains in equilibrium. So now we move on to question 7. The diagram below shows a water reservoir used to run a power station 500 meters below its as shown. So we have a water reservoir, then the height in between is 500 meters, then we have the power station. Let's look at what else we have. Then if the mass of the body of water in the reservoir is 10 raised to the power 11 kg, how much gravitational potential energy is stored by the power in the reservoir? So we have potential energy is equal to, we need to have mass times gravity multiplied by our height. The mass is given 10 raised to the power 11 times gravity is 10 newtons per kg. Then the height we saw that we are dealing with the 500 meters. And make sure that as you are finding this, the height must be in meters and the mass must be in kg. So we will say 10 raised to the power 11 times 10 times 500, and we know that the units for potential energy are joules. So we want to find it. We are looking for an answer like this. So the answer here is just D. Then we move on to question 8. Which statement about thermal radiation is correct? It is infrared radiation. No. It involves movement of atoms. It can only occur in a vacuum. So this is true. Question 9. The diagram below shows a mercury thermometer whose bulb is immersed in pure melting ice and then in steam from boiling water. So let's look at what we have here. So when the thermometer was placed in melting ice, the length was 3 centimeters. Then the same thermometer was placed in steam. Then we can see that we have 23 centimeters. Then the columns of mercury are 3 centimeters and 23 centimeters in the ice and steam respectively. What is the temperature when the column of the mercury is 8 centimeters? So how do we calculate the temperature? So the formula is this one. So we say temperature is equal to, we are going to have X divided by Y multiplied by 100 degrees Celsius. Now, what is X? So we need to find the X. So x is found by, we need to find the length of mercury, which is 8 centimeters. So you say 8 centimeters. Always you subtract the length when the thermometer was placed in melting ice, so minus 3 centimeters, and we can see that we are getting 5 centimeters. So this is our x. Then y is just the difference between the length when the thermometer was placed in steam and the melting ice. So this one is 28 centimeters minus 3 centimeters. So this will give us 25 centimeters. So temperature is equal to our x is 5 centimeters over 25 centimeters multiplied by 100 degrees. So centimeter can cancel. So 5 divided by 25, you get 0.2 times 100 degrees Celsius. So if you multiply by 100, you get 20 degrees Celsius. So this is how you calculate the temperature. So remember, if maybe you are facing issues on understanding this, so the point is you will always be given the length when the thermometer was placed in melting ice. Then for these two numbers, for 23 and 8 centimeters, if you forget which one must be the denominator and the numerator, the point is the smaller number is always going to be on the numerator. The denominator will always be the larger number. Question 10. A wave of frequency 1000 Hz travels between 2 points P and Q with a velocity of 330 meters per second. What is the wavelength of the wave? So you know that velocity is equal to frequency multiplied by wavelength. So we can divide by frequency so that we make wavelength the subject of the formula. So according to this formula, if we make wavelength the subject of the formula, then the formula becomes is equal to, we need to have velocity. So we know that the velocity is 330 over the frequency. The frequency we have been given, we can see that we have the frequency over 1000 Hz. So what is 330 divided by 1000? So we are going to get 0.33. So 0.33 meters as our answer. So our answer is just A. Move on to question 11. 3 vibrating objects, P, Q, and R, produce waves in air of different frequencies as shown in the table below. So P has 25, Q 1000, R 15,000. Which of the above objects produce sound that can be heard by the human ear? So for us to understand or to be able to get the answer, first we need to look at the human audible range. So this is just the range or the sound that can be detected by the human being. So, and we know that that range is between 20 to 20,000 Hz. So the question that we are going to ask ourselves is, the first will begin with 25. Is 25 between 20 to 20,000? Yes. So this one can be heard. Is 1000 between 20 to 20,000? Yes. Is 15,000 between that range? Yes. So we can see that all these three sounds can be detected by the human ear. So the answer here we are going to have D. So sounds that can not be detected is a sound with a frequency less than 20 or above 20,000. So that's now beyond the human ability of detecting sound. Okay, we move on to question 12. The diagram below shows a ray of light directed to a plane mirror at 90 degrees. Okay, then the question is, what is the angle of incidence and the angle of reflection for the incident ray AO? Okay, so now let's see if we can redraw. So we have a plane mirror here, then we have the normal ray. So if light were to come in this direction, then it hits the plane mirror, then we are expected to have the reflected ray in this direction. Then the angle in between the normal ray and the incident ray is what we call incidency, angle of incidency. Then the angle between the normal ray and the reflected ray is what we call angle of reflection. Now, here, the angle of incidence equals the angle of reflection. Now, what happens if the incident ray hits the mirror at 90, if it comes at this or if it is traveling perpendicular to the reflecting surface? So at this point, we are not going to have an angle of incidence and angle of reflection. So the answer is just D, because if this light hits here, the reflection will occur in the same direction. It is going to move in the same direction. So we move on to question 13. Of the statements given below, which one is correct? X-rays have a lower speed in air than visible light. No. X-rays and visible light travel at the same speed. These travel at the same speed. Then for B, microwaves have a longer wavelength than visible light. So if we were to look at the arrangement of these, then infrared, no, gamma rays have a longer, so the answer is just B. Microwaves have a longer wavelength than visible light, because if you look at the arrangement of these electromagnetic waves and on the electromagnetic spectrum, we know that we are supposed to begin with we have the first one is radio wave. From the radio wave you have microwaves. After microwaves you have infrared. Then from the infrared you have visible light. Visible light we have ultraviolet. Ultraviolet, then we have X-rays, then gamma rays. So if we look at the wavelength, the radio waves are the waves with the longest wavelength. So that is the key point. But if we look at the arrangement, we're going to see that microwaves have a longer wavelength than visible light. Now, question 14, the diagram just shows a step-up transformer. So step down transformer. So step down, it's a transformer where we are expected to have the low voltage on the secondary core. So what is the size of current flowing in the primary core if the bulb is working at full normal brightness? So the input is 240, the output is 60. So we want to find by what ratio is this number. So the question is, we want to find the current in the primary coil. So for this question, current in the primary coil must be less than in the secondary coil. So how can we find this given power? So for us to find this, we are going to say you get the power output. So the power output is the one on the secondary party, then divided by the power input 240, which is on the primary coil. So if we divide the 60 by 240, I'm getting 0.5. So 0.25. So this is the answer, though the question seems to be incomplete because we only given a power. But if that is the case, this is the relationship that we can just use. So the answer is just here. Okay, so we move on to 15. A metal wire is placed between the poles of a magnet. The wire can be moved in each of the three directions, OP, QR, and ST. So in which direction or directions must the wire be moved to induce an EMF across the ends? So for us to produce the electromotive force, we need to cut the magnetic field lines. So the magnetic field lines, we know that they are moving in this direction. So for EMF to be induced, we need to cut. So we can only move in the direction of OP. So it's OP here. So move on to question 16. The diagram below shows an electric circuit with a known resistance, mark X. We have switch here, then X 80 ohms, then 0.8 amps, 12 volts. Calculate the value of resistor X. So we say this is resistor 1, resistor 2. So the formula for total resistance as long as it is connected in series, we just have to add the given resistance. So it's resistor 1 plus resistor 2. So we can see that resistor 1 we don't have, resistor 2 we have it. So how can we find resistor 1? So we are first going to find the total resistance, since we are given the total voltage and the total current. So what is resistor? Total resistance. So this will be voltage divided by current. So the voltage is 12, the current is 0.8. So what is 12 divided by 0.8? So I'm getting 15. So this tells me that the total resistance that was produced by these two resistors were 15 ohms. So where there is RT, we put 15 ohms. Then resistor 1 is what we are solving for, so we just put X, plus resistor 2, we have it is 8. So if we collect the like terms, this will be 15 ohms minus 8 ohms. Then we have X. 15 minus 8 will give us 7 ohms. Then is equal to X. So this means that here we have 7 ohms, and it's making sense because 7 plus 8 will give us the 15, which was the total. So the answer is just B. The diagram below shows an incomplete circuit. 4 wires of different length and thicknesses are connected in turn between points X and Y. If the switch is closed, which of the following wire will cause the greatest reading on the ammeter? So for us to have the greatest reading on the ammeter, what is the ammeter? Ammeter measures the current. So the key point is which of these wires will allow a highest flow of current. So the question is like indirectly asking us, we want to find a wire that has the lowest resistance. Okay, so let's look at the multiple choice. Long and thick. Thick, yes. So thick, a thick wire has low resistance, but the longer the wire, the higher the resistance. So this is not the answer. Then here we have long, it's not the answer also. Then the answer is C, short and thick. Current easily flows in a short wire and thick wire. Then question 18. Paul has a 2K watts heater. The Zesco electric meter at his house shows that there is only 3 kW units of electric left. How long will he run his electric heater before the units run out? So here is just like a relationship. So we know that the units available were 2 kW per hour. So the point that we can say here is, we know that for this 2k watts, it's like this. So we'll say 1 kilowatts, or we can okay, so say 1, okay, let me just go direct. I wanted to see if I can make an equation. So if I want to go direct, the key point is in this 3 kilowatts per hour, we want to divide the 2 kilowatts so that the kW will cancel. Then if we divide 2 into 3 will give us 1.5 hour. So what is 1.5 hour? 1.5 is just 1 hour 30 minutes, because 5 is half. 0.5 is half. So 1 hour 30 minutes. So this is the point, but I wanted to make an equation that will simplify stuffs here. Okay, so maybe this is just enough for now. Okay, so now we move on to question 19. A radioactive element 22, mass number 86, emits 2 alpha particles, 2 beta particles, and 4 gamma particles. What will be the final composition of the nuclide formed? Okay, so let's look at the first emission of 2 alpha. So we have X 2, 22, 86. So the first emission of alpha, we know that if an element emits alpha, the mass number reduces by 4 units. So 222 minus 4, we get 218. Then here we are going to have 84. So we form Y plus this. So this is our first emission. Now we can see that we want to emit 2 alpha. So let's do another one. So Y with 218, then 84 emits the second alpha. So 218 minus 4 will give us 214. 84 minus 2 will give us 82. Then we will say this is our Z plus He for 2. Now we are done with emission of 2 alpha particles. Let's go to 2 beta particles. So what happens when an element emits beta particle? So if this is our element 214 with 82 as our Z, whenever it emits a beta particle, the mass number will not change, so 214 will remain the same. Then the atomic number must increase by 1, so this 82 plus 1 is 83. Then we'll just say this is the element A plus the nuclide notation for beta. Then we need to look at the last one, 214, 83. So we know that 214 will not change because beta does not change the mass number. Then 83 will become 84. We'll say this is our B plus E0 minus C. Then we know that 4 gamma particles, this will not change anything, because when a radioactive element emits gamma radiation or gamma particles, the mass number and the atomic number does not change. In terms of these two numbers, it will never change. The only change is just there is a loss of NH from the parent atom. So we are dealing with 214 and 84. Now the question is, what will be the final composition of the nuclide formed? So the proton is just 84. We even have the answer here. So this will be our answer. Proton cannot be 82, cannot be 130, cannot be 83. It's 84. Why? The number below here is our proton number. Then what of neutron? If we want to find a neutron, we know that this will be the mass number 214 minus 84. So if you subtract 84 from 214, you get 130. This number here. Then for electron number is also 84. Then we move on to question 20. The diagram below shows a decay curve for a radioactive substance. Okay, so now let's look at the question. Then what is the half-life of the substance? So let's look at first we need to find the original amount of this substance before disintegration is 80. Since this is the point where our cable is touching the y-axis. So for us to find the half-life, first we need to find half of the original number. So half of 80 will give us 40. Then after we are done finding 40, we are going in the y-axis where there is 40. Then we'll draw a straight line parallel to the x-axis. Then upon touching the curve, we need to move down parallel to the y-axis. The point at which this line will touch the x-axis is our final answer here. So this can be 11 minutes. So let's see if we have 11 minutes. So from multiple choices, we can see that we only have 10, 20, 30, 40. So the answer is 10 because 10 is closer, is the closest to our answer. Now we move on to question 1 of section B. So we can see that this section B 45 marks. Answer all questions in this section. Write your answers in the spaces provided on the question paper. Okay. Then we are dealing with a simple pendulum. Figure 1.1 shows a simple pendulum. And this simple pendulum, its arrangement, it has a fixed point. So we have a string, bulb. Okay, so now, if the bulb of the pendulum takes 0.5 seconds to swing between extreme positions A and C, calculate the period of oscillation. Now, the formula here is, we know that the period is denoted by capital letter T. Then the formula is small letter t over n. So time taken divided by number of oscillation. Time taken, we know that t is 0.5. So now we need to find the number of oscillation. Okay. Now there are some more points that I want to share with you. I want to give you some of the concepts. So now these concepts that I'm going to share with you, make sure that we have this arrangement of letters. So like we have A, B here, then C here. So the first point here is, if the question was if the bulb moves from A to B, then the number of oscillation N will be equal to 1 over 4. 1 over 4 is same as 0.25. Then if a bulb moves from A to C, N will be equal to 1 over 2 or 0.5. So 0.5. Now what if it moves from A to C, then back to B? Then the number of oscillation N will be equal to 3 over 4. which is same as 0.75. Now for the last point, we'll say A to C back to A, to its original position. The number of oscillation is 1. So for us to have 1, the bulb must move from A to C, then back to A. We have 1. Now since we are looking at if it moved from A to C, then we know that A to C is half, which is 0.5. So here the answer will be T is equal to 0.5 divided by 0.5, and this will give us T is equal to 1 second. Now what is really meant by this? So what this means is we know that from A to C it takes 0.5. Then from C to A it will also take 0.5. We know that if we add 0.5 plus 0.5 will give us 1. So what is period? Period is just the time taken to make one complete oscillation. So this means that every after 1 second, one complete oscillation was produced. Now let's move on to question B here. Question B, calculate the frequency of the pendulum. So frequency is just now the number of oscillations that are made per second. And here we can see that the period is 1. The period is 1. Okay, if the period is 1, what will be the frequency? The frequency will also be 1. So in this case, frequency is equal to period if it's 1. Why? We know that the formula for frequency will be 1 over T. Then frequency is equal to 1 over 1, which is equal to 1 Hz. This means that per second, only one complete oscillation was made. And this is very true because of the period. We know that 1 second was taken to make one complete oscillation. Then if one wants to answer, to check for frequency, the other formula, we can say frequency is equal to it's N over T. So if you interchange or swap the letters, this also will be our frequency. So 0.5 divided by, we know that number of oscillation A and C is 0.5. Also here will be 0.5. So we know that this will give us same 1 Hz. Now, so for this is how we can handle this question. Now let's move on to question C. State whether the frequency of oscillation will increase, decrease, or remain the same if the first one, the length of the string is increased. So let's see if we have a picture here. Let's say we have this arrangement. The first one, we have the bulb here. Then this is put to this point and allowed it to freely move. Then another one has the same, but this time we want we increase the length here. Then we pull this and we let it flow. So the point is, will the increase in the length changes the frequency? So now let's look at the relationship between frequency and period. From there, we'll be able to see what really will change or happen here. So we know that let's say period is equal to 2. Then the second one will say period is equal to 4. So let's calculate frequency. If period is equal to 2, then frequency will be 0.5. Now let's calculate the second frequency when period is increased from 2 to 4. So this will be 1 divided by 4, which is giving us 0.25. So I want you to take note of this. We increase period from 2 to 4. What happens to frequency? the frequency changed from 0.5 to 0.25. So we can see that frequency reduced from 0.5 is greater than 0.25. So the point is, if period increases, then the frequency will decrease. So these two are inversely related. Why? Because if one increases, the other one will decrease. So let's go back to this diagram. So between these two arrangements, which one will take longer to move from point T? Let's say if this is our A to C back to A. So the one with the longer length will take time to move from this point up to here, then back to here. So this one will give us a higher, greater value in terms of period. I know that whenever the period increases, the frequency will decrease. So the increase in the length of the string will increase period. I know that whenever a period increases, the frequency will decrease. So we'll say the frequency will decrease. Then if for Roman number 2, the mass of the bulb is increased, so this will not change. The mass does not affect. This will not change. Okay, so now we move on to question B2. Figure B2.1 shows a distance time graph for a car traveling along a straight road. Now, when it comes to graphs of motion, I'm asking you to be extra careful here, because sometimes you may get this question wrong, not because you don't know, because you interpret this one, or you may mistake it for a velocity time graph. So we are dealing with a distance time graph. So the distance time graph must be treated differently from the velocity time graph. Why? Because in the y-axis here, we have distances. So let's say if this is our 0, so here we can just say here there was a 10, then here we have 30, here we have 50. Okay. Now, there are some points that you need to know about this type of a graph, or a curve rather. So what are the interpretations that we can have? Okay, let's look at the questions, then we'll be able to make some interpretations. So the first question is, describe the motion of the car between points C and D. C and D. So we can see that between C and D, the line is not linear, it's not straight. So the curve is bending. Then the type of the way it is tells you something. I want you to compare CD and AB. The AB is like this. Then CD is like this. So for a distance time graph, for this one, we have the acceleration. Why do we have the acceleration here? Because velocity is changing. Remember, the acceleration is only at a point when the velocity is changing. Why do we say that? We know that the definition for acceleration is the rate of change of velocity. So if the velocity is not changing, then there is no acceleration. So at point AB, we have a positive acceleration because it is not straight, then it is changing in this direction. But for this one, the velocity is changing. Velocity is changing. Now the change in velocity here, it is decreasing. It is decreasing. So if it's decreasing, we know that the type of acceleration that is at the point where velocity is decreasing, we know that it's deceleration. Then deceleration is a point where, or it's a graph that is telling us that the car is the speed of the car is reducing. It is the car is about to go to rest. So C at D, DE, this point, whenever you see a vertical line, this vertical line parallel to the x-axis under distance time graph, just know that the car is not moving. It is, it has stopped. So I'm sure now you can be able to connect. So at this point, CD, the car is decelerating. It is reducing in speed so that it can stop at D. So here we have the car that is not moving. So say the car was decelerating. So this is what we can say, or the speed of the car was decreasing. So say the speed of the car was decreasing. Okay, let's move on to between which points is the car accelerating. So it's between A and B. Remember, here we have accelerating, then CD we have decelerating. Then state the distance traveled by the car between AB. So for AB, we just want to find the distance in AB. Now, the point here is, if you mistakenly this graph with the velocity time graph, we know that whenever we are finding the distance for a velocity time graph, we are supposed to find the area. But under this one, no need of calculating the area. So we just want to find the distance at B. So we are going to go at point P, then we move in this direction parallel to the x-axis. So the number at which we are reaching is our distance. So we can see that the number is 10. So the distance traveled was just 10 meters. Okay, then you calculate the average speed of the car between A and D. So say average speed is equal to distance over time. So it's A and D. So we need to find the distance between A and D. So let's go at point D. So point D is here. So we'll do the same. We are going to move in this direction parallel to the x-axis. So we can see that it is giving us 60 meters. Then what is the time? Time will move parallel to the y-axis. Then we can see that the time is 20. So whenever you are trying to find this speed and distance time graph, you just divide the values from the y-axis with the values from the x-axis. So we have 60 meters divided by 20 seconds. So we know that this will give us 3 meters per second. So this means that for every second, 3 meters of distance was covered. Now we move on to question question 3. An 8 Newton force stretches a spring to the 20 centimeter mark on a meter rule. If the extension of the spring is 4 centimeters, calculate the original length of the spring. Okay, so here, so let's say we have this is our spring before the extension. So we don't know the length of this spring before the extension. So consider this one as our x. Then after the 80 Newton force was on, then we had the total length according to the question, 20 centimeters mark. So 20 centimeters is the total. So in this 20 centimeters, we have the original length. Then the point is, we have been given the extension. So we want to see from these 20 centimeters, how much of it was the original. So for us to have that, we need to subtract, because we know that the extended part of the spring was just what? 4 centimeters. This was the extended. So the distance from here up to here is our original. So what can we do? So we'll say 20 divided, minus 4, we get 16. This is our answer. So the original one will be 20 centimeters minus 4 centimeters. So this is giving us, we have 16 centimeters as our original. So before the extension, the spring showed the 6 centimeters mark. So that is the point for this one. Okay, so now we move on to question B. Extension produced by a 10 Newton force. Now, let's see if we can find the equation. So the equation is, we know that the force is directly proportional to extension under the Hooke's law. So if we are to introduce our K, we are going to have KE. And if we make K the subject of formula, so this will give us K is equal to F over extension. So what's our K? K, we know that the force was 8 newtons. Then divided by here, the extension was 4 centimeters. So our constant will be 2 newtons per centimeter. So this means that for an extension of 1 centimeter to take place, a force of 2 newtons must be applied. Now the question is, what is the extension produced by a 10 Newton force? So if we increase from 8 newtons to 10 newtons, what would be our new extension? So if we want to find the extension, the formula is like this. So this will be extension is equal to force over constant. So what's our force this time? Is 10 newtons. So it's 10 newtons divided by, then we know that we are going to have 10 newtons per centimeter. So this will cancel. 2 into 10 will give us 5 centimeter. So this means that if the force changes from 8 newtons to 10 newtons, the extension will also change from 4 centimeters to 5 centimeters. And if you want, we can also find the same answer. We can do this. So we know that 8 newtons is giving us the extension over 4 centimeters. Then what will be the extension if the force changes from 8 to 10? So here we have x, we'll cross multiply. So 8 newtons times x is 8 newtons x. 10 times 4, we get 40 newtons centimeter. Then we divide by 8 newtons. Also here by 8 newtons. So we know that if we are to divide here, we are getting 5 centimeters, because Newton, 8 divided by, 8 into 40 will give us 5 centimeters. So this is what we can answer here. So now we move on to question B4. An electrician of mass 50 kg is fixing a bulb in the corridor on the 20th floor of a building 100 meters from the ground. Take gravity to be 10 meters per second squared. Determine the gravitational potential energy by the electrician on the 20th floor. So we'll say this is our ground here. Okay. Then the electrician is somewhere here. Then the height in between the position where this person is at the ground is 100 meters. So we know that potential energy will be equal to mass, gravity, and height. So what's our mass is 50 kg, gravity is 10, height we know is 100. So this will give us a 50,000 joules. Then the question is, while working, the electrician slipped and fell directly to the ground. State with a reason the amount of kinetic energy the electrician possessed as his body just touched the ground. So kinetic is just 50,000 joules. Why? Because as an object is falling down, the potential energy started to be converted into kinetic energy. So say this is because the potential energy has been converted to kinetic energy. So that is what we do. Then we move on to question C. Calculate the time taken. Calculate the time taken for the electrician to fall from the 20th floor to the ground floor. So time taken here, we'll just consider this as a free fall object. So say, let's look at the data. So from the data, we'll say we have SOVAT. So SOVAT T is for time, we don't have time. Acceleration is acceleration due to gravity, 10 meters per second squared. Then final velocity we don't have. Then an object that is free falling has a 0 meters per second as a speed. Then the displacement, the height, we know that the height is 100 meters. Then we have the equation of motion. So the first one, final velocity is equal to, say final velocity is equal to u plus at. Then the second one, s is equal to u plus v over t times t. Then s is equal to ut plus half at squared. V squared is equal to u squared plus 2as. Now, from this equation, we want to look at the equation that will correspond to the data that we have. So, from these equations, we need to find the equation that has t. So, we need to find where there is t, but where there is no v. Why? We can't have two missing variables. We can't find two missing variables at once. So which equation? We can see that the third equation, this equation here, is applicable. So s is equal to ut plus half a t squared. Now, if we are to put the data here, we know that the displacement, the distance is 100. Then our initial, since it was falling down, the initial is what? 0. So 0 times t plus half. The acceleration is 10 multiplied by t squared, which is 100. 0 times t is just 0. Half of 10 will give us 5t squared over 5. T squared is equal to, we know this will give us 20. Then square root. So t is equal to, what is the square root of 20? Is 4.5 seconds. So now the question is, if you want maybe displacement for this, we can summarize this equation. We can just say S is equal to, we can get rid of ut because we know that u is always 0. So it's just half. Then A is the acceleration due to gravity. We just put gt. So this is the formula that we can use. Move on to question B4. The liquid in glass thermometer A, B, C, D, and E expand linearly with temperature. Okay, then all the thermometers have scales marked in degrees. Figure 5.1 accurately represents the scales of these 5 thermometers. So we can see that we have thermometer A ranges from 0 to 250. Then thermometer B, -10 to 100 to 110. C, 0 to 50. D, 100 to 300. E, 30 to 45. Okay, now let's look at the question. Use the information from the scales of the thermometers in figure B 5.12. 1. State which thermometer has the greatest range. So the thermometer with the greatest range is thermometer D. Why? Because we can see the temperature. So it can measure temperature up to 300. So that is the answer. Then 2, excuse me, state and explain which thermometer has the greatest sensitivity. So the thermometer with the greatest sensitivity is the one that has the ability to detect even a smaller temperature. So from these 5 thermometers, look at thermometer B. We can see that we have a -10. We know that -10 is a very low temperature. This means that there is only a very small amount of energy. So if this thermometer can detect this small amount of energy, therefore it is very sensitive. So it is thermometer B. So we have thermometer B. Then we move on to question B. State 2 advantages of a thermocouple thermometer over a liquid in glass thermometer. So the first one, thermocouple thermometer can measure a very high temperature. That is the first advantage. Then the second is it is strong. It is strong. So you say it is stronger than liquid in thermometer. For liquid in thermometer, they tend to be fragile and easily broken down. So it is stronger than liquid in thermometer. Okay, so that's what we can say here. Then we move on to question 6. Figure B6.1 shows a pattern of a wave on a string. Name the type of wave shown. So this one is a transverse. Okay, then let's look at the next question. What is the period of the wave? So for this one, we are not supposed to do the calculations. We just have to point. So consider this is our point A. This is where the wave. So this is a quarter. Then we move on. So the wave, one wave will be completed almost here. So this is the one wave. So we want to measure from this point up to this point how many seconds are being taken. So that's a period, the time taken to make one complete wave. So the distance, the time taken from point A up to point R, we can see that we have 4. So the period is just 4 seconds. Then how many waves are completed in 1 second? How many waves are completed in 1 second? So this question is indirectly asking us to find the frequency. So we know that frequency is equal to 1 over t. We know that frequency is the number of waves produced per second. So the period is just 4. So 1 divided by 4 will give us 0.25 Hz. So this means that for every second, 0.25 Hz were produced. So if the question comes, how many waves are produced in 1 second? Just know that it is indirectly asking you to find the frequency. Then how far is point R from the rest position? Okay. So point R is here. So the distance from this rest position up to here. So we know that the distance from here up to here is 20. So the distance from here up to here is 20. If this is 20, also the down one must be 20 because these two distances are equal. So it's 20 centimeters. 20 centimeters, and this is amplitude, or 0.2 meters in meters. So it depends where you are giving your answer. Though according to the books, the amplitude must be in meters, so it's 0.2 meters. State two similarities between longitudinal and transverse waves. So the first one, they both involve vibration of particles. Then the second one, they both carry energy. So as a longitudinal and transverse, as these two waves are moving from one position to another, they both carry energy. Then they both involve vibration of particles. The only difference is how the particles vibrate. Under longitudinal, they vibrate parallel. Then for transverse, they vibrate perpendicular to the direction of the wave. And we go to question B7. Figure B7.1 shows an optical pin placed 2 centimeters from a convex lens. Okay. So this means that the distance from where the pin is, this distance is 2 centimeters. Now this 2 centimeters is the distance of an object. Then the image, the distance from here up to here, this will be our distance of an image because this is our image. Then you want to see. Okay. Then on the figure B7.1 above, draw 2 rays to locate the position of the image. So want to draw 2 rays. So the first one, you need to draw a line touching the object parallel to the principal axis. So this is our principal axis here. Then from this point, we are supposed to draw a line in dotted. Make sure that here you draw the line in dotted because it is a virtual image. Then we also have to draw a line that will pass through the center here. Then from this point, you are supposed to draw now dotted lines. So why are we putting this dotted? Like I said, we put the dotted lines if the image is a virtual image. How did we know that this image is virtual? Because it is on the same side, it is upright and on the same side as the object. Okay, so let's look at question B. So if the magnification was 3, how far is the image from the lens? How far? Okay, so magnification tells us how many times the distance or height of an object has been magnified. So we know that the formula for magnification is equal to distance of an image over distance of an object. So the magnification is 3. Distance of an image from the question, we know it's 2 centimeters over, so distance, magnification is 3. Distance of an image is what we are solving for. Distance of an object is 2 centimeters over 1. We cross multiply. Di times 1 is just di. 2 times 3, we get 6 centimeters. So this is the distance of an image. So this means that here we have 6 centimeters, and it's making sense that, so that if we were to find the magnification, we know that magnification is equal to the 6 centimeters divided by the 2 centimeters. So 2 into 6 will give us 3, which is here. So the point is, the easiest point is, if you are finding the distance of an image given the distance of an object and magnification, the formula is you just have to get the given magnification multiplied by the distance of an object. Then let's look at this point here. Using the answer in A above, calculate the focal length of the lens. So the formula for the focal length is 1 over f is equal to 1 over distance of an object, 1 over distance of an image. So 1 over f, distance of an object is 2 plus distance of an image is 6. Lowest common denominator is 6. 2 into 6 is 3 times 1, 3, plus 6 into 6 times 1 is 1. So 1 over f is equal to 3 plus 1 is 4 over 6. You cross multiply. 4 times f will give us 4f. 6 times 1 is just 6 over 4 over 4. This means that the focal length is 1.5 centimeters. So this tells us that if from this, since here is 2 centimeters, so 1.5 is here. So this is where we are going to have focal point number 1. Then here we have focal point number 2. Then also focal point number 1. Then focal point number 2. So this means that if we are to complete these rays of light, this is what we are expected to have. We move on to question 8. Figure B8.1 shows an electric circuit in a cloth dryer containing 2 heaters X and Y connected to a 230 volts power supply. When both switches are closed, the current in X is 3.5 amps. Calculate the power developed in the. So if we were to this, so we know that the source of voltage here is 230. So how much of 230 will go to this point? So it's still what? 230. Even here we are going to have 230. Why? Because we know that voltage in parallel is equal. The two resistors here X and Y are connected in parallel. So for us to find the power, so we know that power is equal to voltage times the current. So we know that the voltage is 230 times the current is 3.5. So if we multiply 230 times the 3.5, I'm getting 805 watts. So this is our power. Then B, the resistance of X is double that of Y. Determine the total resistance of X and Y. Okay, so let's go back. We are told that of X is double that of Y. So let's find the total resistance for X. We know that resistance is equal to voltage over current. So voltage, we know that for X is 230 over, for current, we know that current is given 3.5. So 230 divided by 3.5, so 65.7, which is, we'll just round it off to 66 ohms. So this is the resistor at this point. Now the question is the resistance of X is double that of Y. Is double that of Y? Determine. So Y, since this is double that of Y, then Y must be half of this. So here we're going to have 33. So because this one has resistor 1, then here resistor 2. So resistor 1 66, resistor 2 is 33. So we can now find the total resistance in parallel. So it's 1 over RT is equal to 1 over R1 plus 1 over R2. 1 over RT is equal to 1 over R1 is 66 plus 33. Lowest common denominator is 66. 66 into 66 is 1. So plus 33 into 66, this is just half, is 2 times that is 2. 1 over RT is equal to 1 plus 2 is 3 over 66. Then we know that 3 times RT is 3 RT. 66 times 1 is 66 over 3 over 3. So RT is equal to 22. So this is our total resistance. Okay, so now let's move on to question 9. Question 9. The element X with the mass number 117, the atomic number 58, emits an alpha particle to form Z. So X is the parent nuclide, Z is the daughter nuclide because it was the one that was produced. So the question is, what is an alpha particle? So this is a particle with the 2 neutrons and 2 protons. Then for Roman number 2, write the decay equation which represents the above emission. So the parent is X, 117. The atomic is 58. Now the question is, what happens if an element emits alpha, the atomic number reduced by 2 units, while the mass number reduced by 4 units? So 117 minus 4, we get 113. 58 minus 2 give us 56. then the daughter is z plus h. We have 4, 2 here. So this is our answer. Now let's maybe see what we can discuss on the section C. So answer any 2 questions from this section in the answer booklet provided. Okay, so now let's see the first point here. A train starts from rest at a station. So rest, this means that the initial is 0. Whenever you hear rest, the initial is 0 at a station and travels with a uniform acceleration of 0.5 meters per second for 20 seconds. Okay. It then travels with a constant velocity for 30 seconds. So whenever we have constant velocity, the acceleration is 0. Okay. Brakes are applied and the train decelerates uniformly to rest. So to this, if we have to rest, this means that the final velocity now is 0 in a further 10 seconds. Now the question is, determine the velocity of the train at 20 seconds. So the formula that we are going to use is V is equal to U plus A T. So what's our U? Since it's from rest, the U is 0. Then acceleration is 0.5. Time is 20. So 0.5 times 20 is 10 plus 0. So the final velocity is 10 meters per second. Then use the information above to draw to scale a velocity time graph of the described motion on the graph paper provided. So you need to use a graph paper, but I just want to see what I can do. So you draw the y-axis, then we have the x-axis here. So we know that since it started from rest, we are going to have 0. Now let's look at the numbers that we have. So the greatest number that we have in y-axis is 10. So on the graph paper, you can use, if you want, you can say 2, 4, as long as you're reaching 10. So let's say we just use 5 here, then 10 here, we'll say 15. So this is velocity in meters per second. Then let's look at time. So time, the first one we have 20 seconds. It's then travels with a constant velocity for 30 seconds. So we are going to say 20, the first one, plus 30 is 50. Then and the train decelerates uniformly to rest in a further 10. So you need to add 20 plus 30 is 50 plus 10 60. So in x-axis we need to have 60. So just say 10, 20, 30, 40, 50, 60 times. So here make sure that the scale that you are using must be equal for each. So we can now, the first point is 0.0 because it started from rest. Then the other point, we know that we have the time of 20, velocity of 10. So the other point will be here. So this is the first part, because we know that we'll be able to get the acceleration that was given, because the acceleration that was given was 0.5. So if we are to divide the final velocity 10 divided by 20, we'll get 0.5. Then we know that this moved 30 seconds. So we'll move the first one 10. So the 30 will be at 50. So this is where our 30 is. We know that 20 plus 30, 50. Then it came to rest in the last 10 seconds. So this is our graph here. Then see, using the graph drawn, calculate the retardation of the train. So retardation is just the negative acceleration, final velocity minus u over t. The final velocity, since it came to rest, is just 0. Whenever the light touches the x-axis, it's not the 60, no, you just get 0. So 0 minus the initial is at this point. This is what our initial is, then here is our final. So final is 0. If an object comes to rest, then the initial is this point. You move parallel to the x-axis, so the initial is 10 over the time is 10. So 10 minus 0 minus 10 is negative 10 over 10, which is here we have negative 1 meter per second squared. Then 2, we want the total distance traveled by the train in kilometers. So distance is just you multiply the values in y times the values in x. So we can see that we have a trapezium, so the distance is equal to half, then a plus b multiplied by h. So half a is this distance here up to here. So we need to move down on the x-axis. So it's 20, then here is 50. So we need to subtract 50 minus 20. So our a is 30 plus c. B is just this distance from the 0 point here up to here. So you just get 60. Then the height is this distance from here up to here. So the height is just 10. So 30 plus 60 will give us 90. Half of 10 is 5. So 5 times 9 will give us 45 plus 0, which is 450 meters. Now this distance is in 450 meters, but we want the distance in kilometers. So you say 450 divided by 1000. So this will give us 0.45 kilometers. So now we move on to question C2. Figure C2.1 shows a circuit that a grade 12 learner connected when trying to measure the resistance of resistor R. Okay, so we've seen the arrangement. So what name is given to the energy supplied by E? So this is E. So this is just voltage. Remember, voltage is energy. Then identify the instrument P and Q. So what's our P? P, we can see that it's connected in parallel. So this is a voltmeter. What of Q? Q is connected in series, is ammeter. The ammeter measures current while voltmeter measures voltage. Then what is the component S? So component S is rheostat. Then the function of rheostat, it controls the flow of current. It controls the flow of current. So that's a point here. The table in figure C2.1 shows the different current and voltage readings, the PP obtained by, so the first one 0, 0.2, on the graph paper provided, draw a graph of voltage against current. Voltage against the current. So let me see if I can, how I can best use of this. So you remember, you need to use the original graph papers. Now under graphs in science, you are not given the scale, so you need to make your own scale. So we know that it's voltage against the current. So the voltage will be in y-axis against the current in the x-axis. Now we don't know if this obeyed the Ohm's law or if it did not obey Ohm's law. So now before we even plot, I would prefer first you check if it obeys the Ohm's law. So how? Let's calculate the resistance. So say resistor is equal to, we use the first one, this pair. So it's resistor is equal to voltage over current. So what our voltage? 1.15 over 0.20. So 1.15 divided by 0.20. So I'm getting a resistance of 5.75. Okay, let's try to calculate another resistor, but let's use this point now. So it's 1.65 over 0.30. So 1.65 divided by 0.30. So I'm getting 5.5 ohms. Even here, ohms. So you can see that the values are different. Okay, let's check for clarity. 2.65 divided by 0.50, 5.3. So you can see that the resistance was decreasing. So the point here, since the resistor is not the same, it's not giving me the same value, so the graph will not be a linear, will not be a straight line. So that is it. We know we have the picture of, even if we have not yet drawn. So currently it's up to 1. So say current, so we'll just say 0. Current is 0.20, 30, 75, so up to 1. So we'll just say 0.20, 0.40, 0.60, 0.80, then 1.0. Then in the y-axis voltage, it's 1 up to 6. So we can just use the 1 centimeter to represent 1 unit, as long as we are able to reach at 6. So here I'm just trying to see how I can make best of this, but for you that are using graph paper, make sure you do your best. So 0.0, it's at this point, it's the origin. Then the second one, it's 0.20, 1.5. 0.20, 1.5 is somewhere here. Then 30, 1.65. 30 is in between, 1.65, somewhere here. So 50, 2.65. 50, 2.65, somewhere here. Then 75, 4.10. So 75, 4.0, somewhere here. Then 1,5.55. So this is how I'm trying my level best to make. Then remember to use your graph to find the value of the resistance R. So we have calculated so this is it. You can use any. Now let's move on to question C. The strontium, mass number of 90, 38 as atomic, is a radioactive isotope. A nucleus of strontium 90 decays by the emission of a beta particle. Define the term isotope. So we want to define the term isotope. So what are isotopes? So according to physics, if we look at the isotopes, we are looking at the atoms of the same element, but having the same atomic number, different number of neutrons, which is we say different mass number to simplify. Now, for you to have the actual definition, we'll say an isotope, we'll say these are atoms of the same element with same atomic number but different number of neutrons. So here the whole thing is about neutrons, but to simplify, we say different mass number. So let's take it for instance, if we have carbon 12 and carbon 14. So if we are to find the number of neutrons for carbon 12, so number of neutrons will be 12 minus 6, which is 6. Then here we are going to have neutrons 14 minus 6 will give us 8. So you can see that the number of neutrons is what is affecting the mass number. Then let's go to B. For a neutral atom of strontium 90, state the number of electrons. So strontium 90, we know that we have been given is SR with the mass number 90, the atomic number of 38. So since it's neutral, the number of electrons is just the atomic number 38. Number of neutrons, you need to make calculation. So it's a mass number 90 minus 38. So 90 minus 38, I'm getting 52. Okay. So when the nucleus of strontium 90 decays, it becomes a nucleus of tritium, symbol Y. Write the equation for this decay. So what did we say? What decay? So easy. So the whole decay is about emission of a beta particle. So what happens if we have emission of a beta particle? So we have SR with the mass number 90, 38. So whenever it emits beta, the mass number does not change. The atomic number will increase by 1. So we form 39. Then we have been given the symbol Y plus the nuclei notation for beta. Then a sample initially contains 6.0 times 10 to the power 8 atoms of strontium. If the half-life of strontium is 90 is 29 years, calculate the number of strontium atoms that remain in the sample after 70 years. So let's do this. So time before, when the time was 0 before the emission, the number is 6.0 times 10 to the power 8 atoms. So now we are told the half-life is 27 years. It should be, or 29, sorry for that. So 29. So every after 29, half of this number will decay. So you multiply by half. So what is the half of this number? So it's 6 times 10 to the power 8 divided by 2. So I'm getting 3.0 times 10 to the power 8. Then 29 plus another 29, 58. So here we're going to have 58. So half of this will still decay. So what is half of that number? So 3 times 10 to the power 8 divided by 2. So I'm getting 1.5 times 10 to the power 8. Then what is 58 plus 29? So I have 87 here, and we want 87. So this is what is the concept here. So you need to be dividing by half until you reach the required number of years. So what is half of this number? What is half of 1.5 exponential to the power 8, then divided by 2? So I'm getting 0.75 times 10 to the power, so to the power 8, which is, if what we can write this one as 7.5 times 10 to the power 7 atoms. So these were the atoms that remained. Then question E, a teacher says that the emission of beta particles from strontium-90 is random. Explain what is meant by random in this context. So what is random? So if we look at random in radioactivity, we are looking at the decay. The decay of these materials occurs naturally. Like you can't control. So random, that is what it means in the context of emission. So now how can we define this? So we say random radioactive decay is a random process, which means that it is impossible. You can't tell when a substance will decay. So it is impossible to predict when a particular radioactive will decay. So that's what it means by random. You can't tell when. You don't know if it's tomorrow, maybe today, after 2 years. It's just these occurs randomly. So this is what I wanted to share with you guys. So thanks for your time, and good day.